How about projectile motion? A projectile is an object upon which the only force acting is gravity. There are a variety of examples of projectiles. An object dropped from rest is a projectile, provided that the influence of air resistance is negligible. An object that is thrown vertically upward is also a projectile. Same thing. And an object that is thrown upward at an angle to the horizontal is also a projectile. A projectile is any object that once projected or dropped continues in motion by its own inertia and is influenced only by the downward force of gravity.
A projectile is any object upon which the only force is gravity. Projectiles travel with a parabolic trajectory due to the influence of gravity. There are no horizontal forces acting upon projectiles and thus no horizontal acceleration. The horizontal velocity of a projectile is constant, a never changing in value. There is a vertical acceleration caused by gravity. Its value is 9.8 meters per second squared down. The vertical velocity of a projectile changes by 9.8 meters per second each second. The horizontal motion of a projectile is independent of its vertical motion.
Now we will investigate the manner in which the horizontal and vertical components of a projectile's displacement vary with time. The vertical displacement, denoted by the symbol y in the discussion below, of a projectile is dependent upon only the acceleration of gravity and not dependent upon the horizontal velocity. Thus, the velocity displacement y of the projectile can be predicted by using the same equation used to find the displacement of a free-falling object undergoing one-dimensional motion. The equation we will be using is this. That. Types of
Types of projectile problems. A projectile is launched with an initial horizontal velocity from an elevated position and follows a parabolic path to the ground. Predictable unknown include the initial speed of the projectile, the initial height of the projectile, and the time of flight, and the horizontal distance of the projectile. The projectile is launched at an angle to the horizontal, rises upwards to a peak while moving horizontally. Upon reaching the peak, the projectile falls with a motion that is symmetrical to its path upwards to the peak. Predictable unknowns include the time of flight, the horizontal range, and the height of the projectile when it's at its peak.
For example, an object is launched at a velocity of 20 meters per second in a direction making an angle of 25 degrees upward with the horizontal. What is the maximum height reached by the object? Here's a graph depicting the problem. The formulas of the components Vx and Vy of the velocity and components of x and y displacement are given by and in the problem, V naught equals 20 meters per second, and theta is 25 degrees, so theta equals 25. And, G is the constant, which is 9.8 meters per second.
Okay. The height of the projectile is given by the component y, and it reaches its maximum value when the component Vy equal to 0. That is, when the projectile changes from moving upward to moving downward. It's and also the animation of the projectile.
me do that.
Yes. Here's sine. And we are solving for t.
So solving for t would equal v dot. Okay, you can just look at it. By plugging and chugging, you would get the answer to be 0.86 seconds. To find the maximum height by substituting t with 0.86 in the formula for y, maximum height would equal and all that together would equal 3.64 meters, which would be the maximum height of the graph. And that's how you do projectile motion.